Well, how can we use this? Well, one way we can use this is solving right triangles, given just one side and one of the acute angles. What do I mean by solving a right triangle? That means tell me what the lengths of all three sides are and the lengths of all three angles. Of course, with a right triangle, we automatically know one of the angles is going to be 90 degrees. But let's take an example. If I'm asked to solve the right triangle, given that A is equal to 38 degrees and B is equal to 27 degrees, we need to figure out if I have enough information to solve this. Now, first of all, I want to go over a little bit of nomenclature. You notice now I have my angles in capital A and capital B, and then that third angle is 90 degrees. When we're talking about solving right triangles, in general, the angles are given as capital letters. The sides are given the sides opposite that angle. For instance, the lowercase a is opposite angle capital A. Likewise, lowercase b is across the angle uppercase B, and C is what we know as our hypotenuse. That's the side opposite the 90-degree angle. This is how the problems will be set up when you're given them to solve. Well, if I know that we have one angle equal to 38 degrees, and that side B is equal to 27, we need to figure out where we go from here. Well, first of all, we've just learned that the two angles, the two acute angles in a right triangle, are complementary. That is, if we know one, all we need to do is subtract that angle from 90 degrees, and we get the remaining angle. If we're given that one acute angle is 38 degrees, we subtract that from 90 degrees to get 52 degrees. Well, now we have all three angles, and we have one side. Where can we go from here? Well, hopefully we haven't forgotten that we know a little bit of trigonometry now. And if I know one angle is 38 degrees, and say I want to find that side A, well, I want to find A. I have an angle of 38 degrees, and I also have the side of 27. So what trig function has an opposite side and an adjacent side? Well, I think that's the tangent. So I think if I take the tangent of 38 degrees, because the tangent is equal to the opposite over the adjacent, tangent of 38 degrees for this triangle would be that side A that I want to find, divided by the length of my adjacent side, or 27. So I would find, by cross-multiplying, that length A is equal to 27 times 38 degrees. 38 degrees is not one of our special triangles. It's not 30, 60, or 45 degrees, so we're going to use our calculator and find that that length A is approximately equal to 21.09. Please remember to use the correct mode on your calculator. If you're in radian measure, you will get the wrong answer. And lastly, we have this length of the side C. There's different ways of solving for the side C, but I like to stick with the items I was given in the problem. That is, I was given 38 degrees and the length of that one side 27. So if I want to stick to using those two numbers that I have, what I can do is remember that if I have an adjacent side and a hypotenuse that I wish to find, so if I remember that cosine of an angle is equal to the adjacent side divided by the hypotenuse, then I can use that the cosine of 38 degrees is equal to the adjacent side, which is 27, divided by our unknown, which is length side C, or our hypotenuse. And if I plug this into my calculator after cross-multiplying, I find out that length of that side C is equal to approximately 34.26. And we can stop and make sure this makes sense, that hypotenuse length should be longer than each of the legs, and we see that 34 is in fact greater than 27 and is greater than 21, so this looks like it's correct. We can also check our work by using the Pythagorean theorem to see if 27 squared plus 29 squared was approximately equal to 34 squared.